Hey, welcome everyone to our Cooperative Extension Learn at Home webinar series. This is brought to us by the College of the Environment and Life Sciences, and today's topic is how does freezing and cooking food affect nutritional value? And we're going to hear from Dr. Amanda Missimer in a moment. You want to go right ahead, Amanda?
Did you want to do the rest of the slides?
If you can advance the slides for me, that would be lovely.
I'm in control.
Yes, if you want to go right back to the one right before this, please.
Got it.
Okay, so this is brought to you by Cooperative Extension. If you didn't know, there is a land-grant university in every single state. University of Rhode Island is ours for Rhode Island. And we have a number of different areas of focus, everything from land stewardship, food systems and agriculture, water resources, energy efficiency, and healthy lifestyles. And of course, this one fits into a couple of those categories. And you can go right ahead. And so at Cooperative Extension, we're tasked with bringing all of the good knowledge and research from the land-grant university system to Rhode Islanders and to the communities. And our guiding principles are that we're committed to, in sharing this knowledge, we're helping people improve their quality of life, livelihoods, and the health of our environment. And we believe in social justice, and we strive to deepen our cultural understanding and bring inclusive experiences to address diverse stakeholder needs, which is why we're so glad to be able to offer these online educational opportunities to folks while we're not out there in the communities this year. I'm gonna go right ahead. Okay, just a few housekeeping notes. We would all appreciate if you could please take the survey that will be sent to you via email after this. It will help us see how effective we are in changing knowledge, attitudes, behavior. It'll help us continue to provide this wonderful service to you all, so please take that survey. And we will be posting this recorded presentation to our URI Cooperative Extension YouTube channel, and it will be closed captioned at that time as well. So we invite you to check out that YouTube channel for not only this talk, which will be posted within a week, but a number of other gardening and other topics that we've had over the past month or so that we've been holding these. So we're so glad to have about 22 people on this call. Okay, if you want to advance it one more time and we'll turn it over to you. So I am very pleased to present my colleague, Amanda Missimer. She is a clinical professor in the Nutrition Education Department, and her work is all focused on helping people have healthier lifestyles through education. And so I turn it over to you, Dr. Missimer.
Thank you so much, Vanessa, and thank you everyone for coming today. I'm going to be doing this presentation with my co-instructor here, who's already trying to make an appearance, and hopefully she doesn't get going too much on the barks, but she's already been licking my arms, so hopefully she'll be good. As Vanessa said, I am a clinical assistant professor in the Department of Nutrition and Food Sciences, and I have a co-appointment with Cooperative Extension, where I work with nutrition education throughout all of Rhode Island. My background is in nutritional sciences for a while now at both Penn State and UConn, and I also am a registered dietitian. So I'm happy to answer any questions that you have. Just go ahead and put them in the chat box and we'll get to them. Vanessa, I actually can't see the chat box from my screen. Do you know if there's another way to have that going so I can watch it?
I'm not sure.
Oh, wait. Q&A. Never mind. Now I've got it.
Perfect.
Okay. I just wanted to watch that as
looks different in presenter mode.
as we came through. Okay, great. All right. So the original title of this presentation was, let me go all the way back. How does freezing and cooking affect nutritional value? And that's what I kind of named this presentation when I started thinking about it. But what I realized would have been a more appropriate term was how does food processing affect nutritional value? And I think there's a lot of different ways to think about food processing. So I threw up these pictures to start with. What do you think about when you think about food processing? So take a minute. Imagine what you think. Do you think large scale? Like here we have a ton of cucumbers being washed at once, or individual cans of asparagus being made down here. But it could also be something all the way into your home. So for example, home canning or home freezing, or even just how to break down a pineapple. This is actually something that we teach we have a 2-part food service course in our department, and breaking down a pineapple is one of them. So you have to think about food processing all the way from harvesting the food until you're ready to serve it on a plate and everything in between. Because I think we get caught up a lot of times in hearing this term processed food, but pretty much everything we eat is processed in some capacity. And each step of processing can affect nutritional value. And the big take home from this presentation is that it not always affects food in terms of adverse effects. There's actually some food processing techniques that actually enhance nutritional quality of food. So we're going to talk about those today. So first, a review of food preservation and processing. And again, before I go forward, I want to just mention that there's a lot to this. There's a huge agricultural aspect, there's a food safety aspect, and I'm coming at it from the lens of nutritional quality, value, and quantity. So I always come through all my presentations in thinking about nutrition and what's going into your body. So when we think about food preservation and processing, this is something that has been done since the dawn of time. Think about before refrigeration, what were all of the ways that food was preserved by native peoples? You know, you kill that 800-pound buffalo, what are you going to do? You have to preserve that meat. So these are some of the very common ways that food is preserved and processed: frozen, refrigerated, canned, dehydrated, and milled. So again, thinking about all the way from the origins of food, be it a farm-raised animal product or a plant-based food, and then all the way till you're serving it to your family at dinner. So very long road that it goes through. And that's more food supply, definitely more to look into there. So why did preservation come to be? Exactly that. We had to keep these foods for a longer period of time in order to have food. Remember, it has been probably only in the last 40 to 50 years where food access has been greatly increased, and we're actually producing enough food in the world to give everyone access in this country. So the idea of preservation was something that's incredibly important for a long, long time. So the point of it is to be able to extend that shelf life, and doing so by slowing the rate of microorganism growth. Basically means preventing the spoilage of food. So there's two main ways in which preservation occurs. The first is by limiting water, because microorganisms need that water in order to replicate and to cause spoilage. And so you want to be able to limit that. And the second is by limiting oxygen, because oxygen will also degrade food by the act of oxidation, which I'll talk about a little bit later. So some common ideas for preservation of food for limiting water is using these very common food additives, salt and sugar. And I'm going to talk about those very quickly coming up. Here's an example of taking strawberries fresh from the field and preserving them using sugar and a little bit of salt into this, and also using canning. And that extends the life of the strawberry in the form of jam for a much, much longer time. In order to destroy those microorganisms completely, that's done through usually a heating process. So for example, pasteurization is something that's going to be a high heat and destroy growth of microorganisms at that time from the raw milk, and will give it a longer shelf life. So let's talk about the two very common food additives that have used as a preservative since the dawn of time. So first is our best friend in the world, salt. It makes everything taste great, and it is the best preservative out there. So salt works through its ability to pull water from food. So it in essence causes drying. So you may think about salted cod, which is when fish was caught from the ocean. They wanted to store that fish. Salt was applied in excess amounts, drawing out the water, drying the fish, therefore allowing this fish to be preserved at room temperature without having any decay. So the idea is that water will follow the salt, dehydrating the food, therefore the microbial activity will be decreased. And this is something still used today, which is why salt as a preservative is so wonderful, but because of the excess use of salt as a preservative, it is causing subsequent problems such as hypertension. So our sodium sources, and I'm going to talk about the presentation like this, where I mention something and then I'll also mention its food sources. We can see here that sodium is largely going to be coming from table salt. And I do want to say that salt as a preservative is definitely important, but there are so many other functions of salt in our body. Basically, we need every cell of our body will need salt to allow things to go in and out of every single cell. So it's incredibly important. However, our food sources today provide us very large amounts of sodium, more so than we would ever need in the past. So this is just some information regarding sodium, but what I wanted to show here was that the majority of sodium in the diet is coming from table salt. And these foods don't provide, that are shown here are high sources of sodium, don't really provide that much. So a lot of it will come, 75 to 80% of your daily sodium will come from processed foods. So this is a diagram showing how sodium can increase through the processing period. So let's look here. This is one of my favorites. If we look at an apple, this has 0 milligrams of sodium to begin with, but as that apple is transformed into an apple muffin, it now contains 165 milligrams of sodium. As that apple is transformed into one slice of apple pie, it now has 400 milligrams of sodium. So this is all in the processing and the preservation, because we have to think we want those apple muffins perhaps to be shelf stable as well as the apple pie. So if you look through here as well, changing something like chicken into something like chicken deli meat, it goes from having only 60 milligrams of sodium up to 865 milligrams of sodium. So in terms of processing this food, it is something that you have to consider while it is having a benefit in the food to make it shelf stable. It's also acting as a preservative and having food availability for all. It also is a concern when it's consumed in large amounts. So also keep that in mind when you're thinking about specialty salts. So that's that like pink Himalayan sea salt and that black Hawaiian salt that do add a lot of cool flavors, but they fall right into that same sodium category. So the same thing as traditional table salt is going to be the same with any of those other salts. They all fall into that same count for the day. So, and I don't think I mentioned it. Did I put it somewhere? Oh, it's down here. So one teaspoon of sodium chloride or table salt is equivalent to 2,400 milligrams, and that's the maximum recommended amount for the entire day. So when we do food analysis in many of the courses or when I'm counseling, we see, myself included, we're almost always exceeding that. So it is just something to consider with processing of food. Next, our very famous preservative is sugar. So salt and sugar are pretty much the main two when it came to traditional preservatives before the preservatives of today. And sugar works about half as effectively as salt. And you can actually test this out at your house on the road for melting ice. You'll see salt compared to sugar. Salt will work doubly as fast as sugar. So water will follow sugar in the same way that water follows salt. And it does have the ability to decrease that microbial activity by dehydrating the food and removing the water which the microorganisms need to survive. So also what sugar adds that salt doesn't have the same aspect, because sugar is a more complex molecule and has more binding sites to retain different chains of carbohydrates. It will also preserve the color, the texture, and the flavor, which obviously would be ideal for something like strawberry jam. So next we're going to talk about the effect of processing on specific nutrient content. And I realize this is a very broad topic when I talk about nutrients. So I'm actually going to categorize everything by our My Plate categories: fruits, grains, vegetables, protein, and dairy. So I thought it'd be more fun to do it that way. So first we'll talk about grains. Grains make up a large majority of our diet. And this is something, it's about 45 to 65% of your diet. We get it in a lot of different ways throughout the day. But what we're talking about for the purpose of this presentation is the processing and how this can affect nutritional value. So here we see the processing of grains can cause the loss of nutrients. And those nutrients that are lost are vitamins, minerals, and our BFF fiber. So the way that grain processing works is a very complex process, but I want to review these two words right here: enrichment and fortification, because these are two things that around the turn of the 19th century, right after the Great Depression, when there was not a lot of food availability, enrichment and fortification became incredibly important to prevent disease in our country. So first we'll start with enrichment. This is when some of the nutrients that are lost during processing are put back into the product. So if you see enriched with, That meant that product once had those nutrients, it was lost during processing for a number of reasons: water, heat, light, etc., physical disruption, and then it was added back in. Now, the caveat with that is something called bioavailability, which I'm going to talk about a little bit later. Just because it's added back in doesn't mean it's going to work the same way as it would in its traditional form. The next word we'll focus on is fortification. And fortification is going to be the addition of a nutrient to boost its nutrient content. So I think a good addition of this is if you see very commonly vitamin or orange juice has calcium and vitamin D associated with it and added in. So that's something that's not naturally found in oranges. Well, it is found in low amounts, but it's able to be suspended and added to add additional nutrients to that. Iodized salt is another example, and that's another deficiency syndrome that we saw right around the Great Depression. We saw goiters and issues in iodine deficiency. Therefore, iodine was added to table salt. So that's why you see iodized salt today. That's a fortification. So the way we talk about the loss of vitamins, minerals, and fiber is by thinking about whole grain versus refined grain. So here we have the anatomy of our whole grain, which is our three parts. You have the germ, which is the small nutrient-rich core. And notice what's here. We have vitamin E, our B vitamins. We also have healthy fats and phytonutrients. Phytonutrients are plant-based nutrients that our body doesn't require, but have had added benefits that have been shown. Then we have our endosperm, which is the middle layer, which is basically primarily carbohydrates and has some protein as well. And then we have the bran, which is the outer fiber-rich shell, and it also has some B vitamins and trace minerals. So what happens during the milling process can be defined as three different words. So the next time you're at the grocery store, who knows when that'll be, but the next time you're there, really take a look, because marketing can really get you on the difference between refined, enriched, whole grain, whole wheat, which is not whole grain. So if you think about getting maximum nutrition, you want to look for something that says whole grain. So in refining, it's milled all the way down and the bran and germ are removed. So if we remove the bran and the germ, we're taking away most of the fiber, all of the B vitamins, vitamin E, and the healthy fats. If it's enriched, those vitamins are added back into the product, but I'm going to talk about bioavailability coming up. They may not act the same way as they would in the original whole product. So with a whole grain product, you can ensure that you're getting all three parts of the whole grain. So here's the difference between polished rice, which is milled and refined, and then here we have whole wheat over here. So when you're looking for the whole grain, make sure that it says the actual word whole grain. If it's something that's enriched, that means again that it was added back in. So bioavailability is a concept of thinking about the actual amount of nutrients in a product and then the actual amount of nutrients that will be received and utilized by your body. So yes, it may say that it has 200% of niacin, but when you actually would measure that in plasma of a person, it would only be about 20%, for example. So that comes with the way that these nutrients are carried throughout our body and the idea of water solubility and fat solubility, which is something I'll talk about during vitamins and minerals. Here I put as an example for bioavailability, the idea of taking in too much of something and it actually then loses its bioactivity. So for example, the body needs about 65 to 90 milligrams a day of vitamin C. If you would take something like a high dose of vitamin C here, you would be getting between 1,000 and 2,000 milligrams, and that's simply not absorbed. The body can't take in more than it needs of vitamin C because it's a water-soluble vitamin. Therefore, all of that emergency that you consumed will just be pushed right on through and not taken in. So in that case, it can not only cause the blocked absorption of other nutrients that are trying to use the same pathway, it can also cause unnecessary GI side effects. So just something to think about there. All right, our next My Plate category is dairy. And dairy is one of the most processed foods when it comes to retention of its original nutrient breakdown. And that's because milk is so interesting. So oftentimes when food is low fat or low sugar, it has to go the other way because fat and sugar and salt are really going to give you a lot of flavor. So if you'll notice, be careful at the grocery store. If you see like low fat or no fat yogurt, you'll notice that the sugar is much higher. That's because they're looking for that balance and flavor. Milk is one of the only products that retains its nutritional content, but the fat is able to be scaled down. So you have your whole milk, your 2%, your 1%, and your skim, but your carbohydrate and protein numbers stay the same. That's what makes milk so interesting. I'm a huge fan of milk. I think it's a really wonderful, wonderful product. So here we can see all the things that dairy provides to us. But here there is some fortification with vitamins A and D that are lost during processing and then also are added back in. So let's look at pasteurization here. So this shows all of the different ways that milk can be modified, and all of these products too. With yogurt now, you can find whole milk yogurt, 2%, 0%, and then that sugar is unaffected, which actually makes it quite interesting. And that sugar being lactose found in milk. So pasteurization is going to be high heat for a very short time, and the purpose of this is to kill potential pathogens that are found in raw milk. Although what happens with that is then when we look at the nutrient breakdown, we see that the mineral calcium, vitamin A, vitamin D, the B vitamin, riboflavin, and niacin are not affected by the heat because it is a very short period of time. There is some minimal loss of thiamine, which is another B vitamin, and vitamin B12. However, this is the first caveat we see with processing. While there is a minimal loss of these, milk was never considered a good source of these nutrients to begin with. And that goes down to labeling, which I didn't actually mention in this presentation, but I'll talk about it right now. So labeling, when something comes through as a nutrient, it can be a good source or an excellent source, depending on the percentage that was in the original food. So that's something you always want to look for. So if this was not considered a good source, then the loss is insignificant. So same with vitamin C. Vitamin C is very heat sensitive, so this is lost during pasteurization at about 20%, so still some is left. Milk is a good carrier for vitamin D because it has a good fat content and it carries its fat in something called micelles, which can also carry vitamin D. So during the turn of the century, again, with the Great Depression, there was a condition that was on the uprise called rickets, which is vitamin D deficiency seen in children. Osteopenia is what that's called in adults. So osteomalacia, excuse me. So at that time, milk, bread, eggs was a core of the American diet. Vitamin D was fortified into milk as it is a good carrier for that fat-soluble vitamin. Therefore, they were able to decrease the incidence of rickets across the country. You also may notice that milk is carried in an opaque container. And that is because the B vitamin riboflavin is extremely light sensitive. If you've ever taken a multivitamin and you've noticed after you go to the bathroom, maybe then 1 or 2 more times, your pee is like neon yellow, that's the riboflavin. So it's very light sensitive. And so the reason it's in the opaque container is to prevent the milk from light exposure and keep that as a good source of riboflavin. So milk's really got it all. There we go. So our next category is protein. So protein can be animal-based or plant-based, but I'm going to be more talking about the animal effects or the effects of cooking on animal protein, and then plant-based would be more in line with the fruit and vegetables. So this is a good source of micronutrients such as iron, zinc, and also our B vitamins, but it's also a great source of protein. So one of the most important ways that protein can be absorbed is actually through heating. So protein denaturation is the concept that protein as a whole needs to be broken all the way down from a complex structure into individual amino acids. And those individual amino acids are what are able to be utilized in the body to rebuild muscles, rebuild cells, rebuild everything that we need to do with protein in our body, make enzymes, make signals, very busy. So by cooking protein and naturally denaturing it, you actually help your body in digestion of protein and you make that protein more usable by your body. So in that case, cooking is very important. So I always think about denaturation with my personal favorite nutrition item, that's eggs. So when you think about denaturation, you think about that clear egg white, and then when it becomes white, you know that those proteins are then unchangeably denatured and they're all broken down. It's very easily digestible. Eggs actually have the highest quality protein of any protein, and that is dependent on their amino acid profile, digestibility, all of these things. Yes, very quickly, I will answer this question. There is a change with lactose-free milk. So going back to milk really quickly, what happens in the processing is they actually take lactose, which is a disaccharide, meaning two sugar molecules, and it's broken apart because individuals with lactose intolerance have reduced ability to break down lactose on their own. So in the processing of lactose-free milk, that's actually freed. So you have glucose and galactose, which join together to make lactose. So by breaking them apart, that lactose-free milk is nutritionally the same because those monosaccharides are there, but they're able to be consumed by individuals with lactose intolerance. And actually, it's a little bit sweeter because glucose is a little bit sweeter than lactose. All right, so back to eggs. As I was talking about cooking and why it has favorable impacts on protein, also there is a protein in the egg white called avidin. And this actually, when consumed in its raw form, will bind and prevent the B vitamin biotin from being absorbed. And biotin is very important. It has a lot of different functions throughout the body. So this was actually seen in baby chicks that when they were consuming a certain feed that had raw egg, that they had very severe biotin deficiency. And that's a lot of times how we find these vitamins and minerals, through deficiencies. So I always make the joke from Beauty and the Beast, when Gaston eats 12 dozen eggs every morning to help him get large. You can do that, but make sure that they're not raw because you will have a very serious problem with biotin absorption. So in that case, when we cook eggs and other proteins, we're actually able to have them be more bioavailable and helpful to our body. Also, by cooking, iron is going to be released. So we think about how iron is bound to our red blood cells as it travels throughout our body. By heating that and breaking down the protein that surrounds iron, iron is more available. And we'll actually see that later, that in one of the studies I looked at, iron actually became 25% more available than in its pre-cooked form than in its uncooked form. So what we're seeing here is that everything will act differently. Welcome to nutrition. Here's a little bit on biotin, and you can see some of the foods that it's found in, primarily in our meat products here. Also a little bit in some fruits and vegetables as well. So if we look at the cooking effects on protein, it not only will improve its digestibility, but it will also improve its appearance and flavor. So this is in the palatability or the acceptability of different foods. So it's something that can occur through heating temperatures and times, depending on what level of browning you would prefer. Now, I say that with a caveat because, like anything, there is raw, cooked to a certain degree, and then overcooked. So what happens when you start to get into that very high heat or a very long time of cooking protein? It can actually go beyond unraveling and denaturing the protein into damaging the protein to the point where it's now not usable by the body. So that's something that we need to consider, because at these high heats, the amino acids will become so changed that they'll be unable to be utilized. So that can happen through the formation of something called free radicals, which does damage to cellular membranes. And in that case, it can, again, affect the quality of the protein, the palatability, and may also produce undesirable changes, such as the development of carcinogens, which have been associated with the charring of meat. So I do advise caution on the consumption of charred food. All right, so now we'll talk about fruits and vegetables, our next two categories on my plate. And very quickly, fruits and vegetables, they've got it all. They've got vitamins, they've got minerals, they've got fiber. So those are going to be our big take homes from fruits and vegetables. And they also have those phytochemicals again, which I do have a slide coming up on that, those extra plant chemicals that may have added benefits, a lot of times as antioxidants. So here's our vegetables slide. And we can see, again, good source of micronutrients, fiber, phytochemicals. So I've kind of lumped fruits and vegetables together under micronutrients because that's kind of what we're talking about. So micronutrients are classified as the vitamins and minerals because we need them in smaller amounts than our macronutrients, which are carbohydrate, fat, and protein. So here you can see that micronutrients have a role in every single body system that we have. So we definitely need to make sure that we're getting them, and fruits and vegetables are going to be our best source of micronutrients. So here's just a very brief overview of vitamins because I wanted to talk quickly about the difference between fat soluble and water soluble because I did mention that. So very quickly down here, we have fat soluble vitamins. They're best absorbed with other foods containing fat. They take a different route through absorption and transport throughout our body, and they're able to be stored in our body. Water soluble vitamins are absorbed very quickly. They just pass right on through our small intestine. They can go wherever they want because our body is a watery environment. What's different about a water soluble vitamin is it's not stored. So if you don't use it, you lose it and out it goes. So that's why taking in the right amount of water soluble vitamins is best for your body. So here are some dietary sources of vitamins and minerals. As you can see, they fall into every category of my plate. And just because they're in one category doesn't mean that's the only place you're getting them from. It's just the majority place that you would be getting them from. So things that people are typically deficient in would be something like folic acid or dairy. I'm sorry, something like folic acid or vitamin D. So those are two big deficiencies that we're seeing right now. All right, so what about losses? So this paper was showing the losses of B vitamins due to cooking of food. And one of the big reasons why B vitamins are lost during cooking is because all B vitamins are water soluble, meaning that when they're cooked in a watery environment, they're likely to follow the path of the water and leave the food. Now, just because you're having some cooking losses of B vitamins doesn't mean like, oh, well, we're never eating broccoli again. You're just going to lose a certain percentage of this. So here we can see riboflavin and niacin, two of our B vitamins, and you can see the difference between these two. So riboflavin, as we mentioned with milk, has the ability to be destroyed by light, and conversely, nicotinic acid, which is another form of niacin, has generally slight losses, which means it's pretty stable for heat. However, down here with folic acid, which is something that's really necessary during pregnancy and the development of a healthy fetus, is very great for most foods. So we see that a lot of that is lost during cooking. So that's definitely something to consider if an individual is attempting to get pregnant and is not on an additional prenatal vitamin. So here's just an overview of some of those B vitamins that I talked about. Riboflavin, again, we talked about exposure to light, breaking it down. Here are some sources. As you can see, it's found in protein sources, dairy, as well as some green and vegetables. Niacin, our other B vitamin that I just mentioned, pretty heat stable. So also notice here that it's enriched into cereals as well as found in meat products. So that's why something down here, which I'm not sure what product 19 is, but that's something that would be enriched. Usually that's like Life cereal, multigrain Cheerios, shows that it would meet 100% because it's able to be fortified. And again, niacin is something that got fortified due to another deficiency syndrome. This one's called pellagra, which again, right around the turn of the century was something that really affected areas that corn was a large component of their food sources. And lastly, folate is another B vitamin. As I said, this is very heat susceptible. So down here, this was something that was fortified back into flours, enriched in. You can see here it is in Life cereal, because again, this is incredibly important for central nervous system development and preventing neural tube defects in pregnancy. So what about vitamin C? Vitamin C is also a water-soluble, temperature-sensitive vitamin. So this is something that's easily degraded in cooking, especially during elevated temperatures for a long period of time. So these vitamin C and fat-soluble vitamins were collected from this paper, and they measured the nutrient content of the raw food compared to the cooked food. So this had severe losses because, again, this is going to be heat sensitive. So vitamin C is best consumed in a raw food form. Other recommendations for cooking is minimal cooking water or cooking for shorter periods of time, which is something you'll see as a blanket recommendation for B vitamins as well as vitamin C. So vitamin C, again, largely found here in fruits and vegetables. That's going to be your main take home for vitamin C. So try and get that in its raw form to have best absorption. So what about our fat soluble vitamins? Here I put 2 question marks because cooking actually helps fat soluble vitamins be absorbed in most cases. So that's often because these fat soluble vitamins are locked up in other things. They're either locked up in protein or they're locked up with chlorophyll. So chlorophyll is the plant pigment that makes everything look green. And humans do not have the ability to break down chlorophyll. Our stomach acid doesn't have the ability to break through cell walls. So in that case, heating, because chlorophyll is extremely heat sensitive, helps to break down those plant walls and actually freeze a lot of these fat soluble vitamins and phytochemicals. So here we can see vitamin K is relatively heat stable, and a lot of it is retained after the cooking process. For that exact reason, it's packed up in those cell walls, able to be broken down. Vitamin K is preserved. Same with vitamin E. This not only shows breakdown, but it actually shows significant increase in the availability of this vitamin after cooking. Now compare that in green vegetables to potatoes. So notice in potatoes, which have a much higher water content and a lower chlorophyll content, will lose more vitamin E than something like a green vegetable that has more chlorophyll. So, and again, that works by the cellular disruption of those plant cell membranes, therefore retaining more of those fat soluble vitamins. So here's some vitamin E foods. Vitamin E is one of the more temperamental fat soluble vitamins because it can be destroyed through oxygen as well as light and heat. It works as an antioxidant in our body, so it's constantly looking for free radicals to grab onto, and that's going to be things like oxygen and high heat. Here's our vitamin K sources. We see green leafies are a big one. Gotta love kale on there. Kale's one of my favorites. So that's something, again, that can give you a large amount of vitamin K. And also take note that vitamin K is produced in small amounts by the large intestine bacteria that we have. So what about vitamin A? So vitamin A has many different types of phytochemicals that are called provitamin A, and those provitamin A's will then be transformed into vitamin A within our body. So you may have heard of some of them. I listed beta carotene here as an example, and then in my research, I worked with lutein and zeaxanthin, which are other phytochemicals. So, beta carotene retention, again, in those cooked green leafies, when they're cooked and those cell walls are softened and released, the vitamin A content is actually higher in the cooked food. So it increases the availability of those carotenoids. Carotenoids, again, is another word for the precursors, beta carotene, lutein, zeaxanthin, and actually helps you take in more, so improving that bioavailability. So we'll bring us back to our best friend, the egg, where when you cook the egg, which is a good source of lutein, it actually breaks down those cell walls and it's able to allow lutein to be taken in much higher amounts. And lutein and zeaxanthin are directly related to the prevention of age-related macular degeneration, which is a degenerative eye disorder where you lose your central vision. So definitely something to consider when cooking those green leafies, and know that you're releasing all of these phytochemicals and these fat soluble vitamins to be better absorbed. So here's some more examples of vitamin A. It is found in low amounts in a lot of foods, except for our green leafies here. So definitely something that is able to be enhanced through cooking. So here's the slide on phytochemicals. Again, I had mentioned these a couple of times. They're going to be plant compounds that are not essential, meaning that we don't need them in our body, but we are able to consume them and they may have beneficial effects, quite often as antioxidants. So this is actually something I was discussing with Vanessa. I would love to do an entire talk about all of these different carotenoids and talk about how they all may have potential benefits. So the variation in nutrient content is something you also just want to consider. Again, we saw some numbers that say, oh, this has 34 micrograms of fiber, but that can vary so greatly. A carrot on one side of a field and a carrot on another side of a field can have completely different nutrient content. So that's why it is very difficult to kind of measure these things, and we're doing our best at guessing because we can't test every single food that comes out there. So just to note here that raw foods can vary, but of course, raw foods are going to be your best and most fresh source of a lot of those heat sensitive B vitamins and vitamin C. So the overall concepts from breaking it down nutrition wise is, again, I have my BFF chlorophyll here showing that heating can free nutrients to be better absorbed. However, it comes with the caveat that heating can also cause the loss of nutrients, especially heating in water. So something to consider when thinking about those. Next is minerals, and minerals are something that are found in food that play a very important role in our body, catalyzing a lot of reactions in many different systems, providing structure and function. So here are some dietary sources. Again, we see minerals stratified throughout the entire MyPlate. So different ones will be better sources, but again, just because they're in that category doesn't mean it's the only source. So what about cooking losses for minerals? This was all over the board because this is the same thing. We can't classify all of these minerals to behave similarly. So in this study, it looked at sodium, potassium, calcium, magnesium, iron, and zinc. And the cooking losses ranged from 0 to 85%. So it's huge. The average loss was about 24%. And again, some of them were lost up to 85%, and then some of them were actually found in higher amounts due to the cooking. So again, I mentioned iron, which is free from its protein bonds, is now actually more bioavailable. So this was looking at the cooking loss of minerals in spinach, and these were actually the best ways found to cook spinach to retain its mineral content. This means blanching. So blanching it and also microwaving it. Microwaving is actually a really good way to preserve a lot of nutrients. It's something we do in our food lab, and the students always hate when I make them eat microwave chicken, but it's actually the best way to retain nutrients because it cooks at such a high heat for a short period of time and is able to innervate that heat very quickly to the center of the product. I only microwave my potatoes. They're done in 5 minutes. All right, so this was when they were now looking at pork as a meat product. So here looking at the loss of minerals from cooking meat, and the best way found to retain the minerals in meat were frying with wet flour or microwaving, as I mentioned. So the best way to prevent loss from minerals is to consume the food with some of the water that it was boiled in. So retaining some of that pasta water if you are making a soup or something with pasta in it. Adding a small amount of salt while boiling, that goes for the ion balance. Remember, water is always going to follow salt. So if there already is some salt in the water, it will actually prevent some of the minerals from being lost from the food due to the balance between salt in the product and salt in the water. It creates more of a homeostatic environment. Avoid overboiling. I'm saying that as a blanket statement. Avoid overboiling and overcooking your food. That's going to cause more nutrient loss. And then select a cooking method for less mineral loss, the two that we highlighted here. The last category of MyPlate is other foods. So these are the fats and the oils, the things all the way that used to be at the top of the food pyramid. But I just wanted to talk about them as well in terms of nutrient loss. So one of the big ways to have nutrient loss in foods that have fat is through something called oxidation. And oxidation can be non-detrimental or it can be detrimental. So here we have two examples. Over here on the right, we have avocados that show some browning. You've probably seen this in your fridge. This is natural oxidation. However, it is starting to break down the fat that's found in avocado. Versus something like here we see on the bottom, which is oil that has reached beyond its smoke point. And now this oil has become what's known as free radical. And a free radical can cause damage in your body. It's what leads to the development of things like cancer. So you want to avoid oxidation to that extreme. Oxidation in general is when food items are exposed to oxygen and the cell membranes are disrupted so that they're no longer able to be identified by our body, and they then cause deterioration in the food through the destruction of the cell membrane. So just think about whether it's natural oxidation that's occurring in a non-damaging way or a causal oxidation. Okay, so I have not that much time left, so I'm going to go a little bit quickly through these slides, but I wanted to now take the food from the nutrition aspect into the specific cooking ways. So again, there's both favorable and adverse outcomes on each of the cooking techniques. So the first is home preparation, and that comes when the food arrives and at your home until you serve it. So there can be loss in something called the as purchased versus the edible portion. So here we can see that this is what you purchase the broccoli as whole, but this is actually what you end up eating. So if the analysis on broccoli was done as a whole, of course, that's going to be lesser so when some of that stalk, which is probably a huge loss of fiber, is considered in these individual pieces. So some losses are seen there. Also home preparation through blanching, sauteing. Again, these vitamins and minerals are going to act as we saw before. The water soluble vitamins B, vitamins, and vitamin C will kind of follow the water, and those fat soluble vitamins may actually become more bioavailable. So let's look at the example here at the bottom. A bowl of peas is steamed on the table, will contain about 35 to 45% of its original raw vitamin C. But what's notable here is regardless of whether it was prepared from fresh, frozen, or canned. So note the difference in the percentages. And the difference in vitamin C between 45% and 35% is going to be like 10 milligrams, so it's negligible. So don't get hung up on where the food is coming from. Think about it in terms of the cooking process, and are you eating fruits and vegetables? I'm happy. I don't care where they came from. I'm happy you're eating them. So we talked extensively about cooking. The slides kind of take home. So it can help break down protein, help make things more bioavailable, kill bacteria, and help things that are kind of anti-digestible, such as insoluble fiber and chlorophyll, become more digestible. So heating to a reasonable temperature, get that food thermometer. I'm a huge proponent of the food thermometer, and we'll keep everything cooked to the right temperature. Blanching is a very quick drop of vegetables into a boil. And by having the high heat boil and dropping them in there for only about 1 or 2 minutes, it does show a lot of retention of the vegetables' nutrients versus steaming or boiling for a long period of time. So if you look at the example down here, steam blanching shows the retention of 90 to 100%. And that would be putting like a steam basket over boiling water. And then actually putting them in the water for 2 to 5 minutes. I'm sorry, this should be 2 to 5 minutes, shows a retention of 65 to 90%, again, because it's very quick. So this does lose, again, some of those B vitamins and vitamin C, but it retains most of the minerals and fat soluble vitamins. Canning is another way that you can preserve food. There's 2 different types of canning. You can have lower temperature, longer sterilization that allows the killing of the microorganisms to infiltrate all the way to the center over a long period of time, or you can do the high temperature, short sterilization. So those are going to have different effects on the food content. Again, it's going to be the same concept with the heat being applied. So the heat is going to disrupt any of the heat stable vitamins such as vitamin C. However, it does show it's only about 30%. For example, in canning tomatoes, 70% of the vitamin C is retained. So in the high temperature short sterilization, it may do actually a better job of preventing the nutrient loss because it is for that shorter period of time. So that's kind of been shown to be the better way to retain nutrients there. If you want to know more about canning, freezing, and drying, Cooperative Extension through our food safety education does offer a lot of tools on this. And I want to do a little plug for Nicole and Sejal here. And if you go to this website up at the top, there is a lot on the workshops as well as PowerPoints on how to do it and a lot of great resources. So that brings us to drying, which is another very long-term technique of preserving food. Again, all the water is removed to prevent that microbial growth. I wanted to show over here that the example, when the dried foods are stored with air, there is loss of these fat soluble vitamins through oxidation. So that's why when you buy something with beef jerky, it's in that like airtight container with that little moisture packet to prevent all the air from getting in there. So just think about, I mean, I don't know if you're eating beef jerky for all the vitamin C, there's certainly better sources of that. But when you do open something that's dried, kind of consume it in a timely manner. Refrigeration and freezing. Again, I think I spoiled this a little bit in the title, but I didn't get to it as much as I had wanted to in this presentation. But freezing is something that's a very effective way to store food for the long term. Typically, it does not result in any significant destruction of vitamins because it is done very quickly as the food is fresh. What will change this is really the distribution. And that's kind of tough because we don't really know what happens between the time it's frozen at the factory and the time it arrives to our home. So thinking about on the truck, is it exposed to light? Is it exposed to heat? Is it exposed to temperature swings? We don't know. That's where there is changes in the nutrient content. So in that case, if you're worried about that, shopping local is your best choice. Go to your farmer's market. You're able to see where the food came from, do the processing on your own. Then you kind of have a better grasp of that. So for short term storage, there's going to be excellent retention of those vitamins, but of course, longer storage, there's more access to oxygen permeability and light. So the example here is half of the original vitamin C in some green vegetables will be lost after 6 months. And I put this picture here to do a little plug for Sagel's doing herb storage coming up in one of the Learn sessions. Lastly, fermentation is another way to store food. This is becoming more popular, and that's the breakdown of food through controlled microbial species. So usually yeast or some sort of other bacteria. I love kombucha, so that's my fermentation of choice. There is no major concern with nutrient losses on here. It's actually a living food, so the nutrients are better preserved. And there is actually potential for increase in B vitamin activity. So the big take home here is that the macronutrients, our carbohydrate, protein, and fat, are going to become more digestible through heating and cooking. And fat is usually going to be unaffected unless it is exposed to air or light over time. And our vitamins and minerals are going to depend greatly on the type of cooking method and how much water they're cooked with. But for the most, our B vitamins and vitamin C are going to be more heat unstable and light unstable compared to our fat soluble vitamins and most minerals. All right, that's it. Any questions? Thank you.
That was excellent. I wish could hear us all clapping. So thank you.
Thanks.
I had a few questions in the chat box. I think you covered the lactose. There was another one on, does sous vide cooking improve meat protein absorption?
That's a good question. Sous vide is a very interesting technique of slow cooking in water at a low temperature. It definitely does protein breakdown, but it actually does what's called gelatinization, which is where water is able to infiltrate the carbohydrate molecules within meat, which gives it that wonderful mouth feel and sort of like buttery texture. So in terms of protein meat absorption, I would say that it's going to work as in the same way as if you would slow cook or something or cook something in a stew. And that's pretty much like the ideal way to absorb protein because it has all that water in there. It's just going to be able to easily get broken down in our stomach. So if you've got the patience for sous vide, I say A-okay.
Awesome. And if anyone else has questions, they can enter them right in the chat box. I had one and I realized I couldn't enter. I typed it, but back to the charred food question and, the connection to it being a carcinogen. Is that just for meat or any charred food like vegetables and meat?
Yeah, that's going to be for any charred food. So anytime that you disrupt or destroy a cellular membrane, it's something that your body is just not going to be able to recognize. And when your body can't recognize it, now it's like, all right, we got to get rid of this. And so that's something that it definitely should be avoided. because it's the same way as our body would work with cellular membranes being disrupted and then having to use our antioxidants to fight them. So basically you're just using up more of your own antioxidants to fight off those charged carcinogens. I know, it's so crunchy and good. I'm right there with you.
Sad, yeah.
I know.
Another follow-up question to the sous vide one. Sous vide isn't in the water, it's in a vacuum.
Right. I'm sorry. Yes. I was thinking about something differently there. I was kind of thinking about like the marinade and then the slow cook in the sous vide. The slow and low is the best way to go regardless in terms of digestibility of protein. Slow and low is going to be how each one of those individual amino acids is going to be able to be denatured rather than just some of them on the top or some of them on the side. So same answer. Yes. It's a great choice.
Wonderful. And I think one more. When will you do the lecture on phytochemicals? So people are interested.
Yes. It is a very interesting topic because there are so many different ones. And there's a lot of data going on about, it's mostly antioxidant activity, but what comes down to it is like, how many blueberries do you need to eat to get the benefit? So I don't know, Vanessa, when are we going to talk about that?
Within the next few months.
Yes.
Soon. Yeah. So keep updated. If you don't follow URI Cooperative Extension on social media, please do, or make sure to check our event page as we're uploading new events and webinars weekly. If you want to, we can just do our few closing slides. Thank you so much, Dr. Missimer. That was
Thank you. Thanks for having me.
So much. One more question. Would you recommend coenzymes to assist with vitamin and mineral loss?
Coenzymes in terms of, oh, thank you. In terms of digestive enzymes or supplements to assist with vitamins and mineral loss? Clarification.
Donna, if you could just respond. I guess while we're waiting for that response, oh, she has both.
Okay, I'll answer it both ways. So digestive enzymes will not really help with processing vitamins or mineral loss. That's going to be more if you have digestive enzymes are helpful if you have things like lactose intolerance or if you have low pancreatic amylase activity and need assistance with breaking down carbohydrates, protein, and fat. Would I suggest supplements to assist with vitamins and mineral loss? That's a whole nother talk. It's a very tempting subject because you think like, oh, I'm losing vitamin C. I'll just take in all this vitamin C through supplements. But really what the big idea here is bioavailability. When you take in vitamin C from an orange, your body is going to absorb it differently than if you take in vitamin C from Emergen-C. And that's not so much, yes, it is going to take it in differently with something like vitamin C. It's going to be drastically different in something like vitamin D from a supplement and vitamin D from milk. You're going to be better absorbing it, getting more of it from something like milk. So from my professional stance, I always suggest whole food sources rather than supplements. If I do recommend a supplement, it is going to be vitamin D or omega-3s. Those are the only two I really recommend. And then folate during pregnancy. Did I answer it?
Fascinating. That's really good. I'll just put in a plug. My name is Vanessa Venturini. I coordinate the Master Gardener program. So we just want to mention if you're interested in learning more research-based information all about gardening and then going out in your community and helping others grow, our applications are available online to become a URI Master Gardener volunteer. And you can learn more on our website as well. If you want to click through, I think there's one more slide, please. So again, if you have specific questions on gardening or in nutrition in general, you can go to the cooperative extension. You just type in URI cooperative extension and it'll bring you to all of our different, we mentioned the food safety resources as well as the nutrition resources. There are a lot of great recipes and things. Specifically back to gardening, we have a gardening and environmental hotline that you can email with any questions. And again, we hope you will join us at our next Learn at Home webinar series. Right now we're doing every Tuesday and Friday, and then we're going down to Fridays, I think, as of July. And general questions, you have the email and the phone number there. So thank you everyone for joining us, and we hope you have a wonderful rest of your day and some successful cooking endeavors this weekend.